question that was asked by one of the DP2 students. Now, this will be of help to any of the AIHL or AHL students. Okay, so this question is actually kind of an easy one if we look at it in three dimensions. Okay, so the question says find the accurate angle between the diagonals of the rectangular prism. Rectangular prism is nothing but a cuboid. So that cuboid having these vectors. Okay, so the XYZ axis that is there. So we'll take this as the x-axis, this as the y-axis, and the perpendicular to both of them as the z-axis. So x-axis, y-axis, and the z-axis. Okay, all three perpendicular to each other. So along the x, it is mentioned that it is 2. Okay, so I'll just mention that, okay, this is 2. This length will be 3 because it's 3j, and 5k will be the length of 5 over there. Okay, so I can actually write them in the form of coordinates as well, right? So that will be 2, 0, 0. This z1 will be nothing but 0, 0, 5. And this one, the 3 can be written as 0, 3, 0. Are we done? Okay, so from this, if I want to make a box, okay, the rectangular prism would go like this. All right. I hope you were able to understand the prism. Now, from the prism, okay, the diagonals that are there, so to find the diagonals, the best way would be to find coordinates that they are intersecting at. Okay, and then find the vectors along that. Because if you notice, this corner one that is there is 0, 0, 0. Okay, it's not allowing me to type. Let me zoom back. Okay, let's reduce this. This one much too big. Okay, let me see if this works. Yeah. So this corner one is 0, 0, 0. Okay, this point over here, which is the below one, right? It is 2 units along x and 3 units along y, and there's nothing along z. So I can just write it as 2, 3, 0. This above point that is there, what will this be? So this will be 2, 2, 3, 5. Okay. Then the next one that is there, which will be which point is unknown. Oh yeah, this point of the diagonal is unknown, right? I can join this and this. You see, they're asking us the angle between the diagonals, right? So the diagonal formed would be this one, the one that is starting from behind. This will be one diagonal, and the other diagonal that um, would be either this one or the other one. Okay, it could be this diagonal as well. Yeah. So it will be a very good idea if we can find the two vectors. And how do we find the two vectors which are passing through them? Okay, so let's quickly write down the. I should write down the coordinates, isn't it? So let's label that is the origin. Okay. Then this one will be A, B, C. Okay, and the other ones will be D, E, F, F, and this one will be G. Okay. So from these, the first one, the first diagonal that I will be taking will be O to F. So OF, the vector will be F bar minus A bar. F bar minus O bar. So this is as good as F bar, which will be 2, 3, 5. Okay. This means 2y, 3j, and 5k. Okay. And the other one that is there, the other one would be BD. I can use BD. So BD will be nothing but D bar minus B1. Yeah. So the vector d bar is, what are the coordinates? D is at the bottom, 0, 0, 5. 0, 0, 5 minus the vector b. Vector b is 2, 3, 0. Okay. So this will be -2, -3, 5. Okay. So if I want to find the angle between them, the formula for the angle between two vectors is cos theta is equal to a bar dot b bar minus magnitude of a, magnitude of b. Okay. So first we find the dot product of the two vectors, and then cos theta will be dot product. So dot product is very simple. You just multiply element to element and add them. So it will be 2 times -2 plus 3 times -3 plus 5 times 5. Okay, the whole thing divided by the magnitudes of them. So that's a good thing that both the magnitudes will be the same. 4 plus 9 plus 25. The root of plus 9 plus 25. Right, so what does it come to? So that's -1 minus 1 plus 25 upon. This will be root of 4 plus 9 is 13. 13 plus 25, that will give us a 38. 38 times root of 38. Same thing. Okay, so it's just going to be 38 in the denominator. This is cos theta. And the numerator would be 25 minus 13, which is 12. 12 upon 38. So theta will be cos inverse of 12 over 38. Cos inverse 38. There you go, 71.5915. So theta is equal to 79.5915 degrees. Okay, cool. So that gives us the answer, the acute angle between the two diagonals of the prism. Take care.